People use their arms in many different ways. The way we use our arms can greatly affect our arm bones. Hi, my name is Sarajane Smith-Escudero, and I'm a senior at the University of Notre Dame studying anthropology and Latino studies.
And I'm Abby Sargent. I'm a sophomore here at the University of South Alabama, where I'm pursuing dual degrees in English and anthropology. We spent 8 weeks here this summer participating in a research experience for undergraduates funded by the National Science Foundation.
In this project, we were hoping to reveal potential activities of early Bronze Age southeastern Arabia. Our research focused on entheseal changes in the arm bones of a 4,500-year-old group from the United Arab Emirates. Entheseal changes are changes on the muscle attachment sites of bones that are caused by habitual muscle usage. These changes can vary greatly depending on what activities you engage in.
The Nar was a transitional period spanning from 2700 to 2000 BCE. People were beginning to form more permanent settlements during this time, rather than moving from place to place herding animals. For food, they relied on growing crops in the shade of date palms, supplemented by marine resources and herding of livestock. With these changes also came a shift in mortuary practices, a term relating to how people treat their dead. While previous groups in the area buried a few individuals in the same tomb, during the Nar period, large above-ground structures with multiple chambers were built to hold the bones of hundreds of commingled or mixed individuals. Some of the people in these tombs were also cremated. Due to these practices, the majority of the bones we looked at had been broken into multiple pieces in prehistory and were burnt to varying degrees.
For this project, we looked at the arm bones from two of these above-ground tombs, Unar 1 and Unar 2, located in the present-day emirate of Ras Al Khaimah in the UAE. Muscle attachment sites on the humerus, the bone of the upper arm, were examined. We specifically looked at muscle attachment sites called fibrocartilaginous entheses, where muscles attach to the bones directly through cartilage. Cartilage is a tough but very flexible tissue. Your ear and nose are mostly cartilage, for example. When you use your muscles, cartilage pulls on the bone, changing how the surface of the bone looks.
We looked at 4 attachment sites, each of which allows a specific movement. The subscapularis, for example, is the muscle that allows for the internal rotation of the arm. The supraspinatus is one of the muscles that helps you move your arm away from your body. The infraspinatus lets you rotate your arm externally, and the common extensor tendon allows you to extend your fingers and twist your lower arm.
Based on the research we did on activities of other groups of people in the region at the time, the group we looked at might have been engaging in production of cereal crops and metal products and the building of stone structures like the tombs we have discussed. We hypothesized that the enthesial changes would not be different between the left and right arms due to their equal use in food processing and building activities. We also thought that there would be differences in enthesial changes between the sexes due to studies done on nearby groups that reveal sex-based differences in activity patterns. We expected to see differences between the tombs based on possible lifestyle differences amongst those interred. We looked at enthesial changes in each of these entheses and scored them using the new Coimbra Method, which was developed in Portugal.
This method splits the entheses into 2 zones and scores different features in each zone. Zone 1 is the margin or edge of the enthesis, and Zone 2 is the rest of the attachment. In Zone 1, we scored how much bone was formed and if any bone was eroded or worn away. We scored the same features in Zone 2, as well as looking for small and large pores and large pits called cavitations. We cited the bones when possible, recorded any features according to our selected method, and estimated sex using specific measurements. This process was challenging due to the burnt and fragmented nature of the bones, but it was exciting nonetheless to get to use this newly developed method.
Though we couldn't look at changes across muscles from individuals since fragments had different amounts of scoreable features, our project still yielded interesting results. When the scores were added up, some fragments had scores of up to 8 out of 14, meaning their entheses displayed big changes, while others had lower scores of 0 out of 14 or 1 out of 14, meaning their entheses were barely changed. This shows differences in habitual muscle usage between individuals.
There were no statistically significant differences in the amount of changes to the entheses of the right and left arms. This may suggest that people were putting equal amounts of strain on their arm muscles, supporting our hypothesis that they were engaging in activities that required usage of both arms. But the lack of difference could also have been affected by the fact that there was a relatively small number of complete entheses to examine. We also ran statistical analyses to figure out if there were differences between the activity patterns of the remains in Unar 1 and Unar 2, as well as between the enthesial changes of the bone fragments whose sexes were estimated. Overall, there didn't seem to be any statistically significant sex or tomb-based differences in activity evidenced in the bones.
Like Abby said, based on our findings, people were using their arms pretty much equally. However, this doesn't mean that they were always engaging in the same activities. They could have been participating in equally strenuous but different activities. During this time, surrounding areas like Mesopotamia and the Indus Valley were becoming increasingly socially unequal. Perhaps the society these people came from was resisting these rising inequalities, bearing everyone equally, no matter their occupation or status in life, in tombs Unar 1 and Unar 2.
By treating everyone the same in death, and especially by mixing individuals within the tombs, markers of social status in life became almost entirely invisible. Members of the community became part of one collective identity after death.
Using different types of inquiry to study the people from Unar 1 and Unar 2 in the future may help us to better understand their activity patterns. Perhaps a method better suited to examining enthesial changes on commingled and fragmented skeletons can be developed. Overall, it was an amazing experience and an honor to get to research the activity patterns of Umanar individuals.
We would like to thank the National Science Foundation for providing the funding for this research, as well as the University of South Alabama for hosting us this summer. A special thanks also goes to our program directors, Dr. Leslie Gregorica and Dr. Jamie Ullinger, for their dedication and guidance during these 8 weeks.
Also, thank you to Dr. Leslie Williams, Dr. Jesse Goliath, Dr. Delwar Hussein, and Dr. Carolina de la Cova for their invaluable advice throughout the course of this project.